I can imagine that for someone that's not familiar with composites, if you say I make airplanes out of hairs, their reaction is
Probably.
what?
We proposed a completely different way how to describe these composites. Composites is the word, how you call this, fiber reinforced polymers. This disruptive way of describing these materials came by looking at a flock of birds flying by. And we saw like basically a flock of birds, starlings, for example, they move, it's called in a coherent motion. They move as a flock because they move together. And we figured out that the way how biologists describe this behavior, that we can translate this behavior to describe our material.
This is Coffee with Martin, where aerospace conversations take off. In this episode, we go to the foundation of aviation, the materials. But more importantly, what it takes to turn an idea into something that actually works in the real world. How do you go from microscopic fibers to structures that carry people across the globe? I'm joined today by Clemens Dransfeld. He is a full professor within the Department of Aerospace Structures and Materials, with a strong focus on manufacturing. Together with Johan van Stuijvesant Meijen, a young robotic engineer, he works at the TU Delft fieldlab of robotics SAMXL. Together we explore composites, manufacturing technologies and the reality of scaling innovation beyond the lab. Because in aviation, the real challenge isn't just inventing something new, it's making sure the world is ready to use it. Let's get into the conversation. So welcome Johan and Clemens to the podcast.
Thank you.
And my first question is always to my guest is what is your favorite cup of coffee?
Ooh, should I go first?
Yeah, go first.
Johan.
Please.
Well, it's definitely not the one at work. Sorry. But no, definitely the one I make myself in the morning with my mocha pot. I buy the beans from the coffee shop that you once opened to roast beans.
Nice, I didn't know that.
Yeah. I go there once every 2 weeks.
Yeah.
And just have my little ritual in the morning.
So pour over coffee.
No, it's with a mocha pot.
Oh, mocha pot, okay.
I grind the beans and then mocha pot.
And for you, Clemens?
Well, the only coffee machine I have is a Bialetti, the one in which you screw together.
Yeah.
And this goes back from my time where I lived in Italy. But actually my favorite coffee, I just had a flashback, is when I lived in Italy, you work in a office somewhere, and then you go down the street, around the corner, in a cafe, you order an espresso, you stand, you don't sit down, and you have an espresso, you chat, and while chatting, and you walk back, basically. That is, in a way, the idea of my favorite coffee.
Yeah. And did it happen already in the Netherlands that you have your coffee like that?
No.
No. So it's culture-based.
It's a bit culture-based, yeah.
So thanks for being here. My second question is, if you're standing at that coffee machine at the TU Delft and somebody approaches you and say, hey, Johan or Clemens, what do you do? Can you explain it in one sentence?
Ooh, in one sentence. It would definitely depend on who is asking, but I would say I'm trying to develop a technology to build the aircraft of the future.
Okay. Well, that sounds cool.
I think it's cool.
Yeah. And you, Clemens?
My answer is a tiny little bit longer, but basically I work with composites. Composites are carbon fibers embedded in a polymer, very strong and light materials. But these fibers are 7 micron in diameter, so 10 times thinner than a human hair.
Yeah.
And my work is, how do I make out of such a thin fiber an entire aircraft? What are all the steps involved? That is my field of work.
I can imagine that for someone that's not familiar with composites, if you say I make airplanes out of hairs, their reaction is
probably
what?
Yeah.
So my first question, or to get really deeper into the topic, is how do you stay on the edge of innovation in your own field?
Particularly in my case, so Clemens here, he gave a very broad answer of what he does. I'm a bit more specific because I'm just working on one technology. And then basically my way to push to the edge of innovation is try to push this technology to the highest level that you can achieve before it's being used in aircraft. And for this, if I really look at how I do this on a day-to-day, sometimes I just have these moments in which I just go to the lab and I do experiments a bit out of feeling, and I try to just do the things I never did before, but for which I have like this engineering sense that tells me you should try this because this might give you an innovative result, and you might find out new things about the technology.
And what's that? I'm curious about that engineering finesse you said. What's that?
It's it's a bit. It's for me. Sometimes it really feels like a gut feeling. So you have, I don't know, in the past months you maybe did a bunch of experiments, and in some experiments you observed some results of which you think, like, hey, there's something happening there, but you never really studied that particularly. So there's maybe this one parameter that in the machine that you can change. And one time, sometimes even by accident, you change a parameter or you forgot to turn it off, turn something on, and it has an effect. And suddenly you see that, and like, hey, wait a second, there's something there. And then my engineering sense says like, okay, so maybe if I change that parameter this or that way. I don't know if I'm explaining myself.
No, but it sounds like a happy feeling in that moment.
Yes.
And do you celebrate that? Or eternally?
It's more actually so that when things stagnate a little bit with the results, then it can affect actually my mood a little bit sometimes. So I could enter the weekend a bit, not with a bad mood, but a little bit grumpy, like, oh, I didn't manage to do this. So then if I have one of these moments in which I get a result that out of nowhere suddenly turns out to push innovation in that technology, then it just positively affects my mood a lot. And actually, for the past 3 months, I don't know what's happening, but I'm entering the weekend always in a very
always
good
happy,
mood.
always happy weekend. It's good to hear.
Things are going very well.
Happy feeling.
Yeah.
We're going to later talk about the technology itself, but for you, Clemens, how do you stay on top of the innovation in your field of work?
I think I stay on top of the innovation by looking at every other field except my field. So I really like to be inspired to analogies by really looking at 360 degrees. You know, sometimes, for example, so I work with composites with these fine fibers that need to be aligned and consolidated, and so you find similar structures elsewhere in nature, for example, or you find, for example, in system biology, people think about how to describe things, you know, for their world, where I see, well, we can use them also in our domain. So I really like to go in completely, you know, tangent fields, medical science, biology, art, anything, philosophy, you know, to be inspired.
And do you have like an example in the tip of your tongue that happened recently, or?
Yeah, one example, for example, we proposed a completely different way how to describe these composites. Composites is the word, how you call this, fiber reinforced polymers. Yep. This disruptive way of describing these materials came by looking at a flock of birds flying by. And we saw like basically a flock of birds, you know, starlings, for example, they move, it's called in a coherent motion. They move as a flock because they move together. And we figured out that the way how biologists describe this behavior, that we can translate this behavior to describe our material. And that is like an unexpected connection analogy, but that proved so novel that other people start picking this up now.
When was this?
Oh, this was maybe 3-4 years ago.
Okay.
Yeah.
Oh, so
that's nice. That
didn't know about
there's proof coming around back to you again that the flock of birds is.
And this is an analogy which you would normally not make, and we were not actively looking at it. But the connections come sometimes the connections are very far outside the domain.
And if you look at because I know what you do. You do a lot of research on the tape line. That's a machine, right? Can you maybe go a bit more into depth about the technology and the machine
Yes.
and the research you do?
So in this journey from a single thin fiber to an entire aircraft,
Yeah.
you have to make intermediate products. And one of the first intermediate product nowadays is that you make a tape. A tape is a unidirectional alignment of fibers, which is provided with its polymer matrix.
Yeah, maybe,
And-
maybe it's good to ring the bell. Polymer matrix.
Yeah, polymer is basically the polymer matrix. So you have these very, very strong fibers, and the polymer matrix is like a liquid, kind of something like a honey that you can melt and push between the fibers.
Yeah.
And then that polymer then at room temperature is hard and it keeps the fibers together. And together between the fibers and the polymer, you get this ultra strong material, these really high properties.
Yeah. And what do you do on the machine?
Yeah, and so basically you have to go from the fibers and the polymer, you have to make this intermediate product, or you can call it a starting product. And we work really on the science, how to make these starting products. And then with these tapes, later on, colleagues like Johan, they will put it on a robot and use the robot to lay it down in a complex shape, for example.
Yeah.
But our work is really the performance of the material is hidden in the intricacies of that starting product.
Yeah.
And so we worry a lot about or investigate how do we have to align fibers, impregnate them, make sure they're as thin as possible, as homogeneous as possible, that the fibers are well aligned, or whether they are maybe a bit moving around. Should they not? Should the fibers be distributed evenly into that polymer?
And what is the biggest challenge in that research?
It's controlling the material at all scales. Maybe to explain that, the largest scale is maybe the aircraft component, which is like a curved shell with ribs.
Yeah.
But then if you go down, the shell itself is composed of multiple layers, and the layers are made out of those tapes. And within the tapes, you have the fibers, which are seemingly all aligned, but not really. And we know also from previous researchers and previous research that very small differences in that alignment at the micrometer scale
Yeah.
have a macroscopic effect on the performance. Can basically make the difference between it's a great material or it's a very bad material.
And I'm curious, because we do that in a lab environment, in a controlled
Yeah.
environment. We do a lot of research on that specific material, but we're not selling the material to an aircraft manufacturer. So what's the next step? Are you in contact with the industry, or does the industry visits us, or how does that process look like?
Yeah, our product is not the tape. We don't have a web shop where you can order our tape. Our product is the knowledge, basically. So we on our equipment, we figure out how it can be done, and that can lead to multiple outputs. Either we explore material configurations that nobody has done before, or we do research on, for example, what is more and more important, circular materials. We reprocess recycled materials, or we make materials with a configuration. For example, we work on ultra thin tapes that have special properties, and we basically what we do, we try to develop the manufacturing technology to make this product. We try to prove the performance, how is the relation between processing and performance. And with this knowledge, we do then often trigger the interests of industry, and the industry can be anybody from a carbon fiber manufacturer or to an aircraft producer who say, could you work with us together? We would like to understand that better.
Yeah, that's good to know. And Johan, let's talk about, let's say, your technology.
Sure.
You do cool stuff with robots.
Yes.
Can you explain the listener what you do?
Okay. I'll try to not get too nerdy on it. Basically, the technology I'm working on is very broadly seen. It's a welding machine. So Clemens just explained how he's very busy with creating these tapes, the material itself. So once you use that material to create panels or components, sometimes in an aircraft, well, aircraft for nowadays is built out of a lot of different components, and these components need to be joined together. So like an example could just very simply be the wing attached to the fuselage, to the barrel. But also at the smaller scale, you have little overlaps that you need to join together. And in our technology, we're trying to weld two parts together. The thing is, there's a catch to this because the reason why we try to do this is because there's this material that we are also strongly pushing for in the Netherlands. Yep. Those are composites with carbon fibers, so these very thin hairs, where the polymer matrix is a specific type of polymer matrix, and that's thermoplastic. So thermoplastic, I don't know if you would want to ring the bell.
Let's do it. Yeah. Thermoplastic composites.
So thermoplastic is the type of plastic that you can melt and reconsolidate again. So, for example, the plastic bottles at the supermarket, those you can melt, and then they become, if they cool down, they become hard again. But there's other types of plastics that are more like they go through a chemical process. Those are called usually epoxies. I don't know if people maybe heard about epoxies.
Let's ring the epoxy.
Epoxy. Oh my! You're gonna have to ring the bell many times. Well, that's the other type of polymer, thermoset, and there you have it's a two-component plastic. So when the two components are mixed, it goes through a chemical process and then it becomes hard. And then when it's hard, you cannot melt it.
It stays like that.
It stays like that.
You can compare it like making a pancake. Huh? It's first it's liquid, then you provide heat, and then it's kind of gets solid, and it will stay like this until you eat it, basically.
Yeah. Then if you heat it up again, you're only going to burn it, or you're not going to make it into the liquid pancake state.
But so you're in a bonding technique for aircraft. But do you know how it's being done right now? What's the current status of technology? How do they connect aircraft parts?
So this is also a bit where I was trying to go. So right now, the materials that are used in aircraft are not this fiber with the thermoplastic matrix. It's either aluminium or thermoset, so the epoxies. And these materials you cannot weld. So right now they're using techniques like riveting. So it's very simply said like bolts to join parts together. Or they're using adhesives. Or in case of the epoxy structures, you can also just, before they go through the full chemical reaction, you can put two parts together that you want to join. Yeah. And while they're in contact, they continue going through that chemical process, and then they become like one piece. Yeah. You call that co-curing. Yeah. But now, because we see this potential for this thermoplastic composites, this new material that in the Netherlands we're actually trying to push for a lot. In order to use the material, you need to have techniques to process the material and to assemble parts made of this material. And one of the advantages of this material is that you can melt it and consolidate it again. So that would be like welding. Mm-hmm. So we are developing a technique to weld these materials. So you mentioned the robot. So actually, I myself don't work a lot on the robot, but I work on the part that is attached to the robot. Okay. That is trying to make contact with two components made of this material, and it tries to generate heat where the two components touch each other, so that they melt, and you apply pressure, and then you can create a very strong bond between the two parts. Yeah.
And then my question pops to mind is why should we use a robot then? If the technique of bonding is separate from the robotic technology?
That's a good question. So first of all, a human would never be able to apply the force that we need in our technology. So to have an idea, the experiments I did the other day, we were applying forces of close to 4,000 Newton, and that would be equivalent to 400 kilos, more or less. So we press onto our parts with 400 kilos. And well, to get a bit of context of my technology, continuous ultrasonic welding, what happens is we have a sort of hammer that makes contact with the parts, and it vibrates at an ultrasonic frequency, 20,000 times per second. It vibrates with a very small amplitude, so you barely see it.
20,000 times per second.
Yes,
Yeah.
yes. 20,000 times per second. The hammer, while it makes contact, it's like vibrating.
Yep.
That causes a lot of friction. And yeah, when you have friction 20,000 times per second, imagine rubbing your hands against each other 20,000 times per second. Well, you could make fire on your hands. This hammer is applying a force of, like, together with other components, of 400 kilos.
Yeah.
We as humans cannot do that. So that's why you need big machines to apply these forces, and then why specifically a robot. So we use a very large robotic arm that can also do very complex movements.
Okay.
So you could also just create a simple structure where you connect a cylinder and apply the force. But the moment you want to weld curved components, so in airplanes the shapes need to be aerodynamic, so you're going to find a lot of curved paths in an airplane. In order to go over such paths, you need a machine that can do complex movements.
And if you look at from the state of art today, you're working on that material compared to when are we going to apply it in an aircraft factory? When are we continuous ultrasonic welding aircraft parts together? What's your idea?
Well, hopefully very soon. I would say so. In the aircraft industry, is a bit conservative because, I mean, of course, we are talking about the lives of people. We need to know what we're doing. So the path of developing a technology, you need to really demonstrate that your product is safe and that you can deliver the quality that they want. But maybe we could be talking about between now and 10 years to be applying it on structures that are not primary. So a primary structure in an airplane is a structure that really carries a lot of load. So in the wings, for example. And we could be already applying the technology maybe on structures which are not primary, so that if they would break, it would not mean that the aircraft crashes into the ocean.
And if you look at these carbon fiber tapes, Clemens, it's already been used, right, in making wing structures?
Increasingly, yeah.
Yeah.
So thermoplastic tapes are slowly being used more and more.
Yeah.
But also, it's a bit the same story. I mean, the aerospace industry is a risk-adverse industry, which when we sit on a plane, we're all very happy about that.
Yeah.
But that also means that basically you first try a new technology on a really small part. If it falls off, the airplane will still fly. And maybe you put it on a bigger part, and if this falls up, it will fly not so good, but it can still make it. And then only when you, over the years, you accumulate experience, and then you're really sure you haven't overlooked anything. This is then you move slowly to very large structures. And but for and in thermoplastic composites originally, the people were working with fabrics. So a fabric is really like a textile, like the clothing we wear.
Yeah.
And these fabrics were then impregnated into thermoplastic. This was called organo sheets. And this had a disadvantage. First, the fibers are like in the weave pattern going up and down. They're undulating, so they are not straight. Therefore, they are not strong. And the other thing is, imagine it's like making a clothing. You buy a roll of textile, and you cut out the pattern, and 50% is waste. About.
Yeah.
And now, if you imagine you assemble your clothes out of UD tapes, you put next to each other, there is hardly any waste, and the fibers are straight and strong. So, and you can apply it with a robot, like similar robots like Johan is working on, and so it is better in performance, less waste, and higher performance, higher level of automation.
So you're only putting the fibers there where the structure needs
exactly
that stiffness.
And it's way easier to tailor to locally put more fibers where you need them. But it is still, in a way, even that there are companies like, given an example, GK and Fokker, who are pioneers in introducing thermoplastic composites to the market. It is still, for example, the vision of making an entire fuselage barrel out of thermoplastic composites really large, or making a wing cover, like the upper lower part of a wing, like a 20 meter part in one shot. This is still a daring venture, and even that on paper the technology exists, but this is a major risk, also in equipment, machinery, to go this way.
Yeah,
but eventually it will come.
And one of you said earlier that the Netherlands is, let's say, big in thermoplastic composites. And
it's a unique setting.
Can you tell me a bit more about that?
Yeah, I think it is a really, I look at it, I only live here maybe 8 years now, so I was always looking with envy, looking at it from abroad. But it is a unique setting of universities and companies emerging out of these university environments, where they had developed very strong an entrepreneurial vision with a few key people who said, we think this is the next thing, and we put all our bets on that. And because of that, material manufacturers emerged in the Netherlands, who were really pioneering, like these fibers and tapes and fabrics also originally. Then companies emerged who were focusing on how do I turn the semi-finished or the starting material into a shape.
Mm-hmm.
Other companies were focusing on how do I design the machinery to make the parts. Other companies were focusing, I need simulation software for this forming process. How do I do that? And so basically, in the Netherlands, for being a smaller country, there is a unique density of competences, academic and industrial, which you find in this concentration, you find, I would say, nowhere in the world.
Oh.
It's really a unique setting.
Huh.
And this, once you have reached that critical threshold, it becomes a bit self-propelling, then people work together, know each other, they do more, they make more progress through collaboration and having good collaboration partners, and this propels itself more.
And then the outside world is going to look at you as the expert.
Yeah, and people come more and more to work together.
And do you know what choices determine such a market entrance for a new material or new part? It's not really trial error, right? So it's how who do you have to convince that your technology is superb?
For this, I have to quote someone. I have to quote Arndt Offringa, GK and Fokker, who is one of the pioneers in really introducing thermoplastic aerostructures. And he said, you have to dare, when you are a smaller player on a global scale, Netherlands is a small player, you have to dare to go a different way. And also what he said, what resonated very well with me, is you have on the other side, on the customer side, on the OEM side, you need one person who believes in you.
Ah.
So, because ultimately it's about trust and taking a risk, and you can do all qualification programs and tests and everything. You can, but still, when you have proven everything and you've proven it works, the price is competitive, the performance, you check all the boxes, still someone has to say, yes, I'm going to do it. But this means that we are going in a completely different journey compared to what we have done until now.
Yeah, so it's a non-technical variable.
Yeah, it's a non-technical, it's a really, it's a human factor.
Yeah.
In spite of all the technology, it's a human factor at the end.
Yeah.
That is decisive to make it, to push it from the lab into an industrial application.
So we are academics, right? So we work in academia. How do we work together with the industry? Because I would say it's a different world, right? So we're not commercial as TU Delft, and then GK and Fokker has to make money out of a product. So how does that knowledge come?
I would say it's very simple. Just listen and understand.
Okay.
Basically, both sides listen to each other, I think industry partners, good industry partners, are very open and curious. What are you doing? Why are you doing it? And we as academics should be very interested in understanding industry. Why do you take this decision? And especially when these are non-technical decisions. What led you to do this? And try to understand. And by understanding each other, you can put yourself into other people's roles that may create the decisive shift maybe in your research.
Yeah.
To say, I'm going to address my problem differently.
And Johan, how do you take your industry partner along in your work?
I work in this research center called SAMXL.
Maybe we should.
Hey, so what is SAMXL?
Yeah.
Smart Advanced Manufacturing XL. We are a research center or a field lab. I've heard many names for it.
Yeah.
But basically just a very big space where technology that was started in the university, so in the faculty. So actually SAMXL is right across the road from the Faculty of Aerospace Engineering.
Yep.
And technologies that originated in the Faculty of Aerospace Engineering. We also have other technologies that maybe originated somewhere else, maybe mechanical engineering. But a lot from aerospace engineering, these technologies where they saw potential of, hey, this can actually be applied in industry, and maybe we need to push a bit more to get this actually out into industry, because often in the faculty, if you have maybe someone doing a PhD on a topic, this person needs to write papers, needs to write a lot of articles. SAMXL is a bit more the spot where we can also do a lot of research on technology, but
more applied.
More applied. So we want to make it work. We don't necessarily want to understand the effect of this parameter on this. So that's also where what I said before. Sometimes I just go to the lab and I just try things out and see what works, because I gotta make it work in the end.
Yeah. And I think it's also because you're at the edge of invention, right? So you cannot you cannot read a book of.
No, I wish I wish I could ask ChatGPT.
Yeah, the computer says no, I think.
Yeah,
if you typed it in. Yeah. So you need the industry as input for your.
Yeah. So this research is indeed the industry. They provide us sort of the requirements. So I want to have this machine, this welding machine, being used in airplanes, maybe also in other industries. We're also looking into that a bit now. But it needs to perform a certain task to build aircraft.
When did you graduate? Last year? 2 years ago?
I think it was exactly 2 years ago.
Exactly.
The 20th of March of.
Yeah, but you work for a university, right? For the field lab of SAMXL. Why did you not choose to go into industry?
So I did my master thesis at SAMXL, working on the technology that I work on now. Once you actually get to experience the freedom that you get from doing research on a technology that you have to push forward, it's hard to let go. So I have other friends that got jobs. They all went to Amsterdam, and I don't see them using their creativity a lot. Or actually, I think that the concept of freedom in work, that is something that I have a lot in, and I think people in universities have a lot. People trust you. They know that you are, or they hope that you are a bright mind. They put you to do a task, and they hope that something will come out. But no one is going to tell you how to do engineering exactly. No one is going to tell you, you have to do. You have an end goal, and you have to get to that end goal. But the path, you can quite tune yourself how you.
Yeah. So they trust you for you being you.
Yeah.
And then you take that responsibility to the next level.
So when my thesis supervisor from SAMXL, which is now my colleague, he proposed me to continue working at SAMXL, it really felt like I felt valued for what I did before. So he really appreciated the way I approached the technology, the little innovations that I could bring to it, and I feel like I'm still very valued. So it's a very rewarding environment. When things go well, it's really it's like this little adrenaline in your body. That's like, oh yes, lovely.
And I think, Clemens, you're a professor at the Faculty of Aerospace. I don't think you woke up someday saying, hey, I want to become a professor.
No, well, maybe you know it, but I remember I think at the end of my high school, I think my father asked me, so what do you want to do? And I said, well, everything except becoming an academic.
So you're kidding.
So I think something went wrong along the way.
Yeah.
But it is maybe a journey. Like I had a very industrial mindset. I really actually it was not at the end of high school. It was at the end of my studies. My motivation to learn skills, I studied material science and later industrial design, was I wanted to make things. I wanted to have the skill to make things. And I made many things. I designed many products, developed many processes that were put into practice. But then behind that satisfaction of being a creator or a maker in a way, below that layer grew a little plant, and that plant is called curiosity.
Yeah.
And that grew bigger and bigger and bigger. And actually through making things, you can satisfy your curiosity also. But at some point, it kind of took over, And nowadays, after having a long industrial career of products on the market, which I can say, well, I designed those, now I take more satisfaction out of really wanting to understand why things work and just on the pure knowledge.
Yeah. And maybe general question for you both. If you look at the aerospace industry, we are all talking about hydrogen flying, electrical flying. What do you see in that new ways of flying or the future of flight in, let's say, the 10, 15 years? Because you're in top of the innovation, let's say invention, right? You're in the front row, so you must know what's going on there. Can you give your opinion about it?
It's complicated. I think we will see a whole array of solutions with different lifespans appearing concurrently. Right now, for example, on the base layer, but very important, is a whole development which is not at all about materials or anything. It's about sustainable aviation fuels.
Yeah.
When you make sustainable aviation fuels, you can take all existing aircraft, fuel them up, done, basically.
Yeah. So with the current technology, you can change.
So already with the current technology, you can change, but that is only part of the answer, And then I think we will see maybe emerging as an emerging plant. We may see electric flight for short-range connections coming, because it seems, in spite of you think batteries are heavy, but as an aerospace engineer, you're an aerospace engineer, you may know, an aircraft paradoxal must not be light to fly efficient, and an aircraft can be heavy. It needs to be light to take off, but once it flies, it can be actually heavy. So battery for short range, that may be a solution, and I think the holy grail is like hydrogen propelled flight for long range distance, where you need to have the hydrogen, you need to cool it down until it becomes liquid, so at cryogenic temperatures, and you need to maintain it in that state, and that is a big deal, in all aspects, probably the most disruptive one in terms of technologies, and that may come even later, and then maybe more, and then for long distance flights. So we will have a layering of solutions and systems, and in the same way we will also see, especially the new, for all new sustainable aviation fuels, for electricity and for hydrogen, compare it to the growth of electric cars. You need the whole infrastructure.
Yeah.
You need airports that have charging stations, airports that have sustainable aviation fuel, airports where you can refuel hydrogen, that must be produced somewhere. So only having the product is only a part of the solution, but when will the infrastructure be there? And it is a bit like
The chicken and the egg.
chicken and egg that goes slowly, like with the electric cars.
Yeah. And you, Johan, how do you see?
Actually,
The future.
so what I was thinking, the first thing that popped to my mind when you asked this question is that within the aerospace industry, actually, if you look at the faculty, it already splits up in a lot of disciplines. So we are mostly working on the structures, but you can change so many things. You can also change the whole aerodynamics. So you can, instead of having a traditional airplane, you can have like a flying V. But for these things to happen, all the different disciplines need to advance. And my contribution from my side is I'm going to try to make the structures as light as possible. And hopefully, so with the technology that I work on, you could potentially make the aircraft lighter and then possibly allow for electric or hydrogen, or maybe it actually allows you to change the full shape of the aircraft because you can manufacture in a different way.
So it's a combination of things. I'll try to reason your answer, but so manufacturability,
yes,
is very important. I think also for you both in your research. When do you take that manufacturability into account? While making your tapes or controlling the robot?
When do we take it into account,
Yeah.
or when does an aircraft manufacturer?
No,
take it?
you, because I think you make a piece of the puzzle where you can take that to, let's say, an Airbus that makes the aircraft.
Yeah.
Or is it not that important?
Well, I mean, the whole reason why my technology exists is because of the good properties of the material that I work with in terms of manufacturability.
Yeah, I think it is intrinsic.
yeah,
When
yeah,
the field
yeah.
where you're working, it is driven by the idea of manufacturability.
Exactly.
And maybe to close off this round of podcasts is, I've prepared 3 questions. There's 2 options, and you have to choose. So
Okay.
Clemens, first you. I'm not flying at all in the future, or I want to fly consciously.
I want to fly consciously.
Yeah. And for you, Johan?
Very good question. Actually, I'm in the process of buying a van so that I can travel more just around Europe.
Electric van.
It should be electric then. That's true.
Yeah.
That's true. Very good question. So I actually see myself in the situation that very often when I have to take flights, it's because my friends want me to take flights and then I have to say no to plans.
Yeah.
So, but in the end, I cannot say no. It's very difficult.
No.
So I would like to also answer with I would fly consciously.
Understand. Second question is that if you look at technology, do you think the technology to progress is already here? We have it in our heads, or no? We need more research. We need more time to develop the technology.
I think it is already there in our minds, in different places, in different disciplines, and we need to put the puzzle together. And putting it together is not just putting it together, but you need to add a layer of knowledge to know how to put it together.
Yeah.
I totally agree. I feel like always with technology, it exists. It's there. Maybe not with a physical product that you can buy, but it is there. And you just need to the courageous people that see it and actually make it into something.
Yeah.
And you need time and invest a lot.
Last question. Do you prefer having the material in your hand or the machine in your hand?
I want both. It's very easy. I could not compromise in between.
No?
Because the machine makes the material.
Yeah.
So especially in the field of composites, you cannot separate between the material and the part. And the machine, that is what in my whole career keeps on fascinating me. The machine makes the material and the part at the same time.
Nice.
And this is like doing magic all the time. So it keeps on intriguing me. So I need both.
Okay.
Sorry.
Now I give you a wild card not to choose. Yeah. And for you, Johan?
Well, I actually love playing around with my machine. So I would say the machine, but the problem is if I don't have material, then there's nothing to do with the machine.
I understand.
But the machine. I would choose the machine.
Thank you, guys. Thank you both for this nice.
Yeah, thank you so much for organizing.
Yeah,
It was
thank
a
you.
lot of
Thank
fun.
you so much for the invite. I think it's a great initiative.
Innovation doesn't end when something works in the lab. That's where the real challenge begins, because the impact only happens when the world is ready to adopt it. Thanks for listening to Coffee with Martin, and tune in for the next episode.